Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. RAID troubleshooting is an essential topic for anyone managing storage systems, and the certification expects you to understand both the symptoms and responses to various RAID issues. These include degraded arrays, failed rebuilds, and mismatched drive configurations. When a RAID array begins to fail, data integrity is at risk, and system uptime may be compromised. A degraded or unstable array may continue to function temporarily, but without proper intervention, it can lead to complete data loss. Understanding RAID fault scenarios is a key skill for the A+ exam, especially for roles involving server or enterprise storage management. The term degraded refers to a condition where one or more drives in the RAID array have failed or been disconnected, but the array is still operational. In this state, the redundancy that protects against data loss is no longer active. For example, in a RAID 1 array, one mirrored drive may fail, leaving only a single active copy. In RAID 5 or RAID 10, a single disk can fail without immediate data loss, but another failure would cause the array to collapse. A degraded status serves as a warning that corrective action must be taken immediately to avoid further risk. Degraded arrays typically trigger alerts through various channels. The system BIOS or RAID controller may display a warning during startup, or a front panel LED indicator may change color to show a failure. RAID management software, often included with the controller, will report the degraded state through its dashboard or log files. Users may also notice a performance drop, missing volumes, or slower data access as the array operates with limited resources. Identifying these warning signs early is essential to prevent the situation from escalating into a total array failure. To address a degraded RAID array, the first step is identifying the specific drive that has failed. This can be done through the RAID controller's management interface or diagnostics tools that display the serial numbers of connected drives and their corresponding health status. Matching the reported drive information to the physical layout is crucial. Drives should be labeled during installation to make it easy to locate the affected unit. Without proper labeling, there's a risk of removing the wrong disk, which could escalate the failure. It is important to recognize that not all reports of drive failure are accurate. False failure alerts may be caused by loose or improperly seated cables, temporary power issues, or misreads by the controller. Firmware mismatches between the drive and the controller can also trigger incorrect warnings. Before replacing a drive, technicians should reseat all connections and perform diagnostic tests to confirm the issue. Replacing a healthy drive due to a false positive can trigger unnecessary rebuilds or even data loss in some RAID levels. When a confirmed failed drive is being replaced, several best practices must be followed. The replacement drive should be the same size and type as the original, or larger if the RAID controller permits it. Drive should always be inserted into the slot designated for that specific array member, which can often be verified through the controller software. In many systems, the rebuild process begins automatically once the replacement drive is detected. In other systems, the rebuild must be initiated manually. Understanding the behavior of your specific controller is critical during this step. The rebuild process involves reconstructing lost data using parity or mirrored copies, depending on the RAID configuration. This process can take several hours or even days depending on the array size and the current system workload. During the rebuild, overall performance may be significantly reduced, and additional stress is placed on the remaining drives. Because of this, rebuilds must be monitored closely to avoid compounding problems. A power outage or user error during this stage could corrupt the array entirely. Sometimes, rebuilds do not complete successfully. If a second drive fails during a rebuild in RAID 5, or if a rebuild is interrupted, the data may become irretrievable. These scenarios highlight the risk of operating in a degraded state for too long. Rebuilds that fail due to power loss, user mistakes, or hardware instability may leave the array in a non-functional condition. At that point, specialized data recovery services may be the only option, often at a high cost and with no guarantee of success. RAID controllers vary in how they handle rebuilds, and this behavior can affect how technicians approach repairs. Some controllers are set to automatically rebuild the array when a replacement drive is inserted, while others require manual confirmation through a software interface. These interfaces may include web-based dashboards or command-line utilities, each with different options and logging features. During a rebuild, the controller typically generates status updates and error messages in its log, which technicians can review to track progress or diagnose interruptions. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One method to improve RAID fault tolerance is to use a hot spare. A hot spare is a drive that is physically installed and recognized by the RAID controller, but remains unused until another drive fails. When a failure is detected, the controller automatically begins rebuilding the array onto the hot spare without the need for manual intervention. This reduces downtime and allows the array to restore redundancy much faster. However, for a hot spare to function correctly, it must be compatible with the existing array in terms of size and type. Proper configuration is necessary to ensure the controller uses the spare as intended. When replacing a failed drive manually, using the wrong drive can create new problems. A drive with a smaller capacity than the original may prevent the array from rebuilding at all, causing errors or leaving the array in a permanently degraded state. While many controllers will accept a larger replacement drive, only the portion of the drive that matches the original capacity will be used. Additionally, differences in firmware, rotation speed, or interface generation between the new and old drives can lead to instability or performance issues. The exam may include questions that focus on the consequences of mismatched drives. Keeping the RAID controller's firmware up to date is another important best practice. New firmware versions often include bug fixes that improve rebuild stability, compatibility with newer drives, and performance enhancements. Some updates may even add new features, such as more efficient rebuild algorithms or enhanced diagnostics. However, updating firmware carries risk. If the update fails or is applied to an unstable system, it can cause array corruption or boot problems. Therefore, firmware should only be updated when the system is stable, and backups should always be completed beforehand. Technicians must also decide when to rebuild an array and when to restore from a backup instead. In a RAID 5 array, if two drives fail, the array cannot be rebuilt because the parity information is incomplete. Attempting to replace drives in this situation may result in total data loss. Instead, the safest option is to restore the system from a previously saved backup. Even in less severe cases, if the state of the array is uncertain or the data is highly valuable, it is often safer to perform a restore than risk a failed rebuild. The exam emphasizes knowing when to make this critical decision. Monitoring systems should be configured to alert technicians to RAID problems before they become critical. Most RAID software supports email alerts, while enterprise systems may integrate with SNMP or other centralized management protocols. These alerts can notify administrators immediately when a drive drops out of the array, enters a degraded state, or begins to fail. In addition to real-time alerts, daily or weekly reports should be reviewed to catch problems early. Relying on manual inspection alone increases the risk of silent failures that go unnoticed until it's too late to recover. A common RAID 5 failure scenario illustrates the importance of timely intervention. Suppose one drive fails in a 5-drive RAID 5 array. The system enters a degraded state and issues an alert. The user ignores the alert and continues to use the system normally. Weeks later, a second drive fails and the array collapses. At this point, no rebuild is possible, and all data is lost unless professional recovery services are used. This example highlights how delays in maintenance can transform a manageable issue into a catastrophic failure. The certification may describe such scenarios to test your awareness of best practices. Diagnostic tools from RAID controller vendors play an important role in monitoring and managing arrays. These utilities typically include dashboards for viewing array health, drive status, rebuild progress, and historical logs. Some tools display smart data from individual drives, giving insight into temperature, error counts, and sector reallocation. Others include command line access for scripting or advanced troubleshooting. Knowing how to interpret these tools helps technicians make informed decisions and resolve issues before they escalate. The exam may present tool output and ask you to determine the correct next steps. After a rebuild completes, the array should be tested to verify it is functioning properly. Technicians may run disk benchmarking tools to check input and output performance, or copy large volumes of data to simulate real-world usage. Unexpected slowdowns, timeouts, or system freezes may indicate lingering issues with the replacement drive or configuration. It is also a good idea to monitor the array for several days after a rebuild to ensure long-term stability. The goal is to confirm that the system has returned to full health and can withstand typical operational demands. Labeling drives clearly and maintaining accurate inventory is an overlooked but critical part of RAID management. Each drive should be marked with its serial number, physical slot location, and the role it plays in the array. This labeling ensures that if a drive fails in the future, it can be quickly identified and replaced without error. Proper documentation also simplifies communication during support calls or handoffs between technicians. For the exam, you should understand how clear labeling supports accurate troubleshooting and helps prevent human mistakes during rebuilds or maintenance. To summarize, RAID troubleshooting requires careful observation, prompt action, and methodical processes. Degraded arrays should be addressed immediately to avoid data loss, and rebuilds must be monitored closely to ensure they complete successfully. Drive replacements should be compatible, and controller behavior must be understood to execute repairs correctly. Alerts and diagnostics help detect issues early, and proper labeling supports accurate maintenance. Whether it's choosing between rebuild and restore or updating firmware cautiously, RAID troubleshooting requires both technical precision and attention to detail. These concepts are tested directly on the certification exam. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.